Now, this loop carries a current that is pointing in the counterclockwise direction. And I want to call this point number A here. So let's say that this is, so let's call this point A, point B, point C, point D. So again, remember from the previous chapter, so a loop here would be A, B, C, D, and A, right? That's a loop. So going from point A to point B to point C to point D back to point A. So that's one loop right there. Now, so the current in this wire has a magnitude I, and this is placed in a magnetic field. This magnetic field is pointing like this. Now, let me see here. So let's say F1. So let's say that there's a force here, F1. So call this force F1, F2, F3, and F4. Now, so F1, is the force between point D and point C to point D. So force between point C to point D. F2 is the force between point D to point A. Then F3 is the force between point A to point B. F4 is the force between point B to point C. Now, if you see how I'm calculating my forces, I'm keeping the same direction of the current. So I'm always going in the counterclockwise direction, right? So when I say the force is between point C and point D, notice that that force is not the same as the force between point D and C. So CD is not the same as DC, right? Because, so D to C means that I'm going in the counterclockwise direction of the current to calculate my force, right? So for example, if you change the direction of the current such that the current goes from point D to point C, then the force will be a negative value, right? So I'm keeping those directions that's in such a way that I'm always going in that counterclockwise direction. Now, let us calculate F1. So again, let me remind you the equation that we're using. So the force is calculated from, so magnetic force is current, length vector, cross magnetic field. Now, in all the problems that I'm going to solve, we can say that the B field vector is some magnitude. And in what direction is it pointing? I direction. And so let's start with A. So let's calculate the force F1. So when I calculate F1 is the magnitude of the current So when we calculate F1, so F1 is equals to the magnitude of the current, which is I. What is the length vector from point C to point D? It's negative I, right? So I can write that as the magnitude of the vector, which is just the length from point C to point D is B, right? And then B into, let's say negative B I hat. again, you just see that this should be 0. Because I hat cross I hat is 0, right? Now let's calculate F2. So F2, again, I. What is the length vector as you go from point B to point A?
Negative AJ.
So negative AJ cross. So we know that J cross I. So I cross J is K, right? So it means that J cross I is negative K. And the negative is with positive. So all of this is just going to be equals to I. A. Does everyone agree with that? Okay. Now let's calculate the force between F3. Do we need to calculate F3? No, it should be 0, right? Because if F1 is 0, then F3 should be 0 as well. So F3 is 0. How about F4? It's just negative F2. So F4 you can do the math, but this would be negative AIA. Now this is the key point here. You see that if F2, so let me draw this. So F2, it means that the force here is a dot. So the force between point D and point A is a dot. The force between point B to point C is a cross. I don't know if, does that make sense? Between point D to point C is coming out of the board, it's in the K hat direction. Again, notice that if this is my I direction, this is my J direction. Then where is my K? It's coming out of the screen, right? So it means that between point D to point A, the force is coming out. And that's how you create. So again, if you look at this. So this point experiences the force that is coming out like this. This force experiences the force. So out and in, that would generate a torque that is going to rotate this object. So as I'm going to show you here, I can show you that, so the loop, so what I want to prove to you is that this loop is going to rotate counterclockwise about J hat axis. And each time that you solve a problem, you need to tell me, okay, is the rotation, is it clockwise or counterclockwise? And what is the axis of the rotation? So there's two things that I'm looking for here. First, I need to know, is it going to be rotating in the clockwise or counterclockwise direction? And this is very important because if the current was going in such a way that, let's say, so right now we have a current that is moving in the counterclockwise direction. If I were to change the direction of the current so that the current moves in the clockwise direction instead, then everything is going to change, right? So it means that when I calculate the force, F2 will be pointing into the screen, and F4 will be pointing out of the screen. And so this will generate a torque that is going to rotate the loop in the clockwise direction, but still about the j-axis. So you can get clockwise or counterclockwise rotation. It just depends on the direction of the current.